Hi guys, thanks for joining. I had to record again during eighth period because for some reason my it stopped recording in the middle of my lecture last period. So here I am, where I am with eighth period, and they're going to help me today with today's recording. All right, so let's get started. We are talking about section 11.4 combination reactions. And of course, all of this information comes from your CK12 packet. So, how useful is a wheel rim? If you've ever gotten a flat tire, you know that driving on the rim of your car is definitely uncomfortable. You feel every single bump on the road, and also you can ruin it. Okay, how useful is a wheel rim? Who's gonna help me read?
I'll read this.
Thanks.
A wheel rim is not a very useful by itself. Driving on the rim can damage it and make for a very rough ride. When the rim is combined with a tire, product can be put on the car by used for a safe and comfortable ride. The two spare items have combined to make something that improves the car ride.
Definitely. Thank you, Gael. So if you've ever, gotten a flat tire, you know what it's like to be with just the rim. It's not very comfortable and you could ruin it. And rims can be very, very expensive if you got those fancy ones that everybody likes. And driving, and you can't drive without a rim and just the tire itself because there's no way to keep it inflated, right? But once you put the two together, you're able to drive 10,000 miles or however long you need to drive. All right. Today, so this combination, is a very useful for us, right? And today we're going to talk about what's known as a combination reaction. Just like the name implies, you are combining elements or small compounds to create something larger. So the definition reads, a combination reaction is a reaction in which two or more substances combine to form a single new substance. Combination reactions also have a second name. They're also known as synthesis reaction. You got to remember that to synthesize means to create. All right. So here, in the case in chemistry, what we're creating either a larger compound from two small compounds, or two elements come together and create a compound, or you can even have a combination of an element with a small compound coming together. All right. The general form for a combination reaction is shown where you have A plus B gives us compound AB. And remember, A and B, it can be any element or any small compound. Okay? Remember, it's very easy to identify a synthesis reaction, mostly because it's the only type of reaction that's going to have two reactants and one product. Okay, so you'll see at least two or more elements or small compounds creating a larger compound. One combination, and they start by giving some examples. One combination reaction is two elements combining to form a compound. So that's like the basic version, right? When you bring two elements together and you form a large compound. For example, solid sodium metal reacts with chlorine gas to produce solid sodium chloride, right? Salt. And here's the reaction below. You have your Okay. Notice that in order to write the balanced equation correctly, it is important to remember the 7 elements that exist in nature as diatomic molecules. And here's your list, all right? And you have the same list on your valence sheet, okay? So there should be no reason for you guys to forget. At the bottom of the page, you can see the list, right? There it is. All right. So in case you run into hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, or iodine, these will be the formulas that you use, okay? Remember, metals, they can stand alone. You'll just write the symbol for that metal. One sort of combination reaction that occurs frequently is the reaction of an element with oxygen to form an oxide. Metals and nonmetals both react readily with oxygen under most conditions. Magnesium reacts rapidly and dramatically when ignited, combining with oxygen from the air to produce a fine powder of magnesium oxide. So again, two elements creating a larger compound. All right. Magnesium plus oxygen gives us that magnesium oxide. So you have your first Pear Deck question. All right. And if you're not in Pear Deck, there's the link. Which of the following are combination reactions? And you got 4 reactions to choose from. Number 1, number 2, number 3, and number 4. Where do we have, or which, and there is more than one, which of the following is a combination reaction or synthesis? Which one can you say, guys? Look at each reaction one by one and decide which one is considered a synthesis reaction and is creating a compound out of either elements or small compounds. Itza says number 2. And you know what, Miss Itza? You are correct. Yes, the reaction between calcium oxide and carbon dioxide creating calcium carbonate is definitely a synthesis reaction. Which one else can you say? Which one else is considered a synthesis reaction? Gael, do you think of it? Number 3. Very good. Reaction number 3. When you have here magnesium plus oxygen gas, yes, it does give you that magnesium oxide. You have 2 elements creating one product, right? Reaction number 1 and number 4, we can easily eliminate, mostly because both reactions have multiple products. Remember, if you are dealing with a combination or synthesis reaction, there can only be one product on the right side of the arrow or our yield sign, okay? So the fact that I have carbon dioxide and water, well, that eliminates reaction number 1. Again, for reaction number 4, you got two products. That's definitely gonna definitely eliminate reaction number 4. Okay. Any questions on this one? Very good. Thanks, Gael. I'm pretty sure it's Gael who's in there because she has trouble when she goes in Pear Deck. All right. Yeah, I figured it was you. Thanks, Gael. All right, so we're going to start off by watching a video where magnesium is ignited. Sorry. And we might run into a commercial. Let's see. Oh, no, we're not. Yay. Oh, come on.
Group 2 metals also react rapidly with oxygen in the air when they're heated. Magnesium is flammable.
All right. So there you see a video of magnesium being ignited and reacting with oxygen to produce magnesium oxide. Kind of looks like a firework, right, guys? All right, let's go back. All right, so now we have some more examples that we're going to talk about. Sulfur reacting with oxygen forms sulfur dioxide. Here is the reaction. It takes 1 mole of sulfur plus 1 mole of oxygen to create 1 mole of sulfur dioxide. Yes, definitely. When nonmetals react with one another, the product is a molecular compound. Often, the nonmetal reactants can combine in different ratios and produce different products. Sulfur can also combine with oxygen to produce sulfur trioxide. So look, we have the same sulfur in both reactions. We have the same oxygen in both reactions, but check out our product. Our product for reaction 1 was SO2. There was only 2 oxygens. Check out this second reaction. All of a sudden, our product has changed. Instead of SO2, we have SO3. We got 1 extra oxygen. Okay? So just because you have the same elements, some reactions between nonmetals can create different compounds. In this case, sulfur trioxide. And look, all of a sudden now I need 2 moles of sulfur. I need 3 moles of oxygen so that I can make 2 moles of sulfur trioxide. Transition metals are capable of adopting multiple positive charges within their ionic compounds. Therefore, most transition metals are capable of forming different products in a combination reaction. So remember those metals that we have in the d orbital or in the middle of our periodic table? Those metals, most of them have multiple charges, and you can see them here on our valence sheet. Titanium, vanadium, chromium, all of these have multiple charges. These are the types of metals that they're talking about. Those are transition metals. They have more than one charge, so they can form more than one compound with the same element. So check it out. Iron reacts with oxygen to form iron 2 oxide and iron 3 oxide. Okay? You got the same iron, you got the same oxygen molecule, and look, our product is completely different. In the first reaction, we only have 1 of each, right? 1 atom of iron, 1 atom of oxygen. Look at the second reaction. Our product has changed. Now we have 2 atoms of iron, 3 atoms of oxygen. And look, you can see that the number of moles of iron has changed. The number of moles of oxygen has also changed. Okay, so you got to be careful with those. Will you be able to predict? More than likely, when they give you the word equation, they'll tell you you're working with iron 2, or they'll tell you you're working with iron 3. Okay, they're not going to just say iron and expect you to know, okay, that's iron 2. Oh no, this is iron 3. No, it'll usually say in the word problem which one you're dealing with. Okay, so you don't have to guess. All right, we got another video. We might have a commercial on this one. Called it. All right, let the time pass so that we can skip over. All right, skip.
So the combination reaction, it's also called the synthesis reaction, is probably the simplest of the reaction types. Essentially, we have 2 things coming together to form a new compound. So here we have substance A and substance B, the reactants, and when they react, we end up with substance AB. And that's a new substance, and it's going to have very different properties than either A or B. If we're to draw the whole reaction out, we'd have something like this. A plus B yields AB. An example would be iron, which is a solid, plus oxygen gas yields iron 3 oxide, which is a solid. Don't worry so much about the S or the G, but you can see the Fe and the O2 come together to form one substance. We want to balance this equation, though, so it obeys the law of conservation of mass, so that we have the same number of atoms on each side. And that would look like this. But again, don't worry about that. You're looking at two different substances coming together to form one. That's a combination or synthesis reaction. So if we had magnesium metal plus oxygen gas, those would combine to form magnesium oxide. That's your combination or synthesis reaction. And we could write it out like this. Again, don't worry too much about the S for solid or the G for gas. You can see the two substances forming one. And again, we balance this just to make sure that we obeyed the law of conservation of mass. So you can see here, we have a strip of magnesium metal, and we're going to ignite that in air. And when we do that, the Mg and the O2 in the air will combine to form a new compound, MgO. It'll also give off quite a bit of lighted heat at the same time. Again, combination reaction, we have Mg plus O2 coming together to form magnesium oxide. Here's the metal before, and then after the reaction, our MgO is a white powder with properties very different than the original Mg and oxygen and air. So pause, take a look at these four different reactions and determine which of the four are combination reactions.
All right, so let's check it out. Which ones can we eliminate, like, easily? Okay, we're looking for combination reactions or synthesis reactions, right? Which ones are not synthesis reactions? What am I looking for so that we can easily distinguish a synthesis reaction from all the other reactions? Okay, Itza's saying that number 1, 2, and 3, reaction 1, 2, and 3 are or aren't synthesis reaction. So are you saying that 1, 2, and 3 are not? Okay, so 1, 2, and 3 are not synthesis reaction. Number 4 is a synthesis reaction. Is that what you're telling me? I just want to double check, Miss Itza. I'm not saying that you're wrong, or I'm not saying you're right. Okay, all right. Yes, well, I would agree that number 4 is definitely a synthesis reaction. Let's look at number 1, 2, and 3. Gael, do you think you got the same thing? Okay, let's look at it. So if we look at this first reaction at the very top, why are you eliminating this one? What's so bad, or what is wrong with this reaction where you have water creating hydrogen gas and O2 and oxygen gas? Why did you eliminate that one, Miss Itza and Mr. Gael? It's supposed to be the other way around, right? In this case, we have one reactant, two products. That is the opposite of a synthesis reaction, right? In this case, we have a reactant breaking apart into its elements, Okay, what about number 2? What about reaction number 2? What's wrong with this one that you eliminated it? The same. What? What about it, Gael? What's wrong with this one? It is opposite. Okay. Well, let's look at it carefully. We have hydrogen gas plus oxygen gas. It's giving me water. I see 2 reactants, 1 product. I don't know. It kind of looks like a synthesis reaction to me. Yes, Miss Itza, I think it's correct now that I look at it correctly. Yes. Now that you looked at it a little slower, Miss Itza, now you're starting to realize that, hey, that might be a synthesis reaction. And you know what? You're right. That is a synthesis reaction. You have 2 reactants, 1 product, ding, ding, ding. That's a synthesis reaction, right? We should have a little bell ringing in our head saying, hey, no, that is synthesis. It is, yes, it is a synthesis reaction. So number 2 and number 4 are definitely synthesis reaction. Let's look at the third reaction. Oh man, look at that. You have 2 reactants, 2 compounds, and then my products. Oh yeah, we can easily eliminate here, right? We can eliminate because the fact that we had 2 products. Synthesis reactions only have 1 product, right? So we can easily eliminate this reaction just because it has more than one product, okay? All right, excellent, excellent, excellent. All right, yes, Gael, you're getting it now. Awesome, that's what I want to hear. All right, let's see. What else is in our presentation today? All right, now we got a sample problem, and I'm going to go into Jamboard for that. Let's go to Jamboard. All right, this is our sample problem for a combination reaction. It reads that potassium is a very reactive alkali metal that must be stored under oil in order to prevent it from reacting with the air. Write the balanced chemical equation for the combination reaction of potassium with oxygen. So they're telling us it's a combination reaction, meaning two reactants, one product. What are my reactants? They give it to me here. They're saying you're reacting potassium with oxygen. All right. And everybody knows the symbol for potassium, right? The letter K. What type of element is it on the periodic table? Well, it's in group 2 on the left side. That's the metal. That's a metal, right? We know all the non-metals are on the right. So just because it's in group 2, we know it's a metal, and we know that metals can stand alone, right? So when I go ahead and write the formula, I'm just going to write the symbol, the symbol for potassium, and that's it. Why? Because metals can stand alone, right? All right, so now we know that it is being reacted with oxygen. Remember, oxygen is part of our diatomic element list. You see it down here? All right. You see that right here. All right. So I need to use my formula of O2. Okay, so let's go into Jamboard and let's add that. O2. They're telling you that it's a synthesis reaction, right? Or combination reaction. We know in a combination reaction, there can only be one product. I have a reaction between two elements. In this case, a metal, potassium, and a non-metal, oxygen. So metals and non-metals, what kind of compounds do they make? Ooh, we're going to go back to December. What type of compound is that when I have a metal and a non-metal? Anybody remember? Isn't that an ionic compound? Ionic compound, so I need to look up the symbol and the charge for both of these elements. So I'm going to go to the valence sheet. My valence sheet, I'm going to find, I can tell you one thing. I can tell you that potassium is on the right side of the periodic or of your valence sheet. Oxygen is on the right side. Can you find the symbol and the charge, guys? What's the symbol and the charge for potassium? Help me out, guys. It's on the left side, over here on the left. All right. I think Gael found it. I know where it's at because, of course, I'm an expert at this. So there it is, potassium, K plus 1. Okay, what about oxygen? What about oxygen? What's the symbol and the charge? It's over here on the right side of the periodic table. -2. Very good. You see it right here, everybody? All right. Now that we know the symbol and the charge for each element, I can use that information and write the correct formula. What's my formula if you have this information? What's my formula, guys? Do my charges cancel out? If they don't cancel out, don't forget, you have to cross them down. What's my formula? K2O. Very good. Potassium 2, oxygen 1, but we don't show ones, right, Gael? All right. Okay, now that I have the correct formula, well, they said that you need to balance it, right? So we need to balance it. We make our list of elements, potassium and oxygen. How many do I have of potassium on the reactant side? How many of potassium do we have? Very good. 1. How many of oxygen? 2. Okay, go to the product side. How many? Potassium. 2. Great. Oxygen. 1. Great. Okay, now your initial gut is going to say, well, I should probably start balancing potassium. Right? Your gut is going to say, hey, start by balancing potassium. But look at oxygen. Check out oxygen. Doesn't it also need to be balanced? Yeah. And if I'm balancing oxygen, well, look at where he's attached to. He's connected on the product side to potassium. So if we start messing with oxygen on the right, that's going to change my potassium also on the right, which is going to affect the potassium on the left. I don't know. Can you see that? Can you see how potassium is here connected to oxygen? So if I try to balance oxygen, won't I also affect potassium? Yes. So let's start with potassium rather than oxygen this time. All right. What am I going to do? I know I need to multiply and I know I need to equal 2. What is going to go here that's going to become my coefficient? What's my coefficient? What do I need to multiply oxygen by? Yes, sir. So that coefficient is going to go in front of the compound where oxygen is. And check it out. Didn't my potassium get affected? Did my potassium get affected when I put that coefficient? Yes. I no longer have 2 potassiums. I've doubled it, right? I've doubled it because of the coefficient. So now my oxygens are balanced, but now my potassiums are off. I have 4 on the right, 1 on the left. What do I got to do to the left side to make them balance? Okay, my oxygens are balanced. I got 2 on each side. But now I have 4 on the right, 1 on the left. What's going to happen? What needs to happen for this one? I need to multiply and I need to make 4. I need to make 4. Remember, this is the number of potassiums. I need to multiply by 4. Okay. There it is. That gives me 4 potassiums. Now I have 4. 2, 2. Everything's balanced. And this is my answer for the question. Hey, Sam. All right. Okay. That is, what's going on? Okay. All right. So look at the answer that they got. They got the same answer we did. 4 moles of potassium, 2 moles of potassium oxide. We're good to go. We're golden. We did it correctly. Combination reactions can also take place when an element reacts with a compound to form a new compound composed of a larger number of atoms. Carbon monoxide, for example. Carbon monoxide reacts with oxygen to form carbon dioxide according to the equation. Right. It's pretty much balancing, except now you need to tell me what type of reaction we're dealing with. All right. So it's a synthesis reaction, mostly because we have our two reactants, carbon monoxide, oxygen gas, and one product. Okay. One product. All right. Everybody see that? Two compounds may also react to form a more complex compound. A very common example is the reaction of oxides with water. Calcium oxide reacts readily with water to produce an aqueous solution of calcium hydroxide. CaO plus H2O makes a very large compound, calcium hydroxide. Sulfur trioxide gas reacts with water to form sulfuric acid. This is an unfortunately common reaction that occurs in the atmosphere in some places where oxides of sulfur are present as pollutants. The acid formed in the reaction falls to the ground as acid rain. And here is the reaction. Definitely a synthesis reaction. Two reactants, one product. Easily we can spot it, right? It says here, acid rain has severe consequences on both natural and man-made objects. Acid rain degrades marble statues like the one on the left in picture A. The trees in the forest on the right in picture B have been killed also by acid rain. All right, so acid rain not only affects man-made statues, it can also affect nature. So we got to be careful with those type of pollutants, okay? So, all right, your last Pear Deck question. Write the equation for the following combination reactions. All right, so they want you to go into Pear Deck and they want you to write the correct synthesis reaction for number 1 and number 2. Okay, so if I can have maybe Gael do number 1. Okay, you have a word problem and I need to see the reaction down here. And they give you the formula, so it should be very easy, Gael. Show me the synthesis reaction for number 1. Mr. Sam, I know you just got here, but I want you to try out number 2. Okay, I want you to show me the combination reaction between nitrogen and hydrogen to yield ammonia. All right, go. You, Gael, do number 1 down here. Sam, you're doing number 2. So Sam, please join us on Pear Deck so that you can do number 2 for us. And if you can balance it, I would like for you to start balancing. If you have trouble or you get stuck, that's fine. I'll go in there and help you. But I need you at least to write the combination reaction. Just try it. Follow the word equation and see what you can do for me. Okay? Just try it for fun. You know, this is my fun as a chemistry teacher. All right. So Gael, I'm pretty sure he's in there writing this reaction. All right, let's check out if Gael's done. He's almost there. Remember, it's a combination. Very good, Miss Itza. Very good, ma'am. Very good. H2 plus O2 yields H2O. Perfect. And then she already did Sam's also. N2H2 yields NH3. Very good. Very, very good. You're a little bit off, Gael. Oh, look at that, Sam. Great job. Arrow, right? Draw that arrow. Draw the arrow. Remember, yields is an arrow, isn't it? And then you have ammonia, NH3. I don't know if you can squeeze it in there. Perfect. All right, Gael, you doing better? Remember, it's a plus, and it's an O2. Make sure that you put that O2 in there. Instead of equals, remember, equal yields is supposed to be an arrow. So can you erase that arrow that you have here? Put the arrow where the equal sign is, and then make sure that you have O2 rather than just O. Make the equals into an arrow. Better. And it's O2. O2. There you go. I see you. All right, perfect. All right, so let me go in here into Jamboard so that we can talk about that. All right, so if I have H2 plus O2 gives me H2O, just like Miss Itza and Gayan said, that's perfect. Sam, you didn't even know, but you were doing synthesis reaction when you wrote this down. NH3, right? Yeah. Okay. Technically, we're supposed to balance these reactions, but we're kind of running out of time, and I want to make sure that we finish the questions before you go. Okay. So let me finish the presentation real quick. Great job, guys. In summary, combinations reactions occur when two or more substances combine to form a new substance. Your questions for today. What are combination reactions? Number 2, write the product of the following reaction. Number 3, is CH4 plus O2 yield CO2 plus H2O a combination reaction? Explain your answer. All right.